Morning, friends. Very good morning and welcome in the next video lecture of uh, electromagnetic field theory. In this video lecture, we will study about the electric flux density and Gauss law. In previous lecture, we have already discussed about the electric charge, Coulomb's law, electric pole intensity or electric field intensity. In this electric field intensity, we have discussed the line charge, volume charge, surface charge or space or differential length charge, point charge. So in a previous lecture, we have already discussed about the charge and electric field intensity and the relationship between the charge and electric field intensity and Coulomb's law. And we have already discussed the some rules regarding the electromagnetic field or electric intensity. Today's lecture is based on the electric flux density Gauss law. Prerequisites to learn this lecture, student able to understand the vector calculus. They have to clear the calculus, mathematical expressions, dot product, cross product, Coulomb's law, electric field intensity, and they are also able to understand the electric charge, charge density. So these are the prerequisites for understanding of today's lecture. The course focus is the electromagnetic field theory. This course is deal to develop the foundation of electromagnetic field theory. The learning objective of this video lecture is that the student will learn and understand the concept of electric charge, charge density, electric flux density, Gauss law. They are also able to understand the Maxwell equations. In the previous lecture, we have already discussed the four Maxwell relationships. So, Gauss law and electric flux density is the law to generate the Maxwell equations. The application of the Gauss law and electric field intensity in the Maxwell equations. Today's lecture is based on the application of the electrostatic field theory or electric field intensity. In the last, we will discuss the several application of electric field intensity. And in the last of this video lecture, we have some multiple choice questions. These are the textbooks and the other recommended books for electromagnetic field theory. SADIQ is the book which is published by the Tata McGrail, and the title of this book is The Principle of Electromagnetic. The main outcome of this video lecture is to clear the concept of the electric flux density, Gauss law, and the application of the Gauss law in the Maxwell equations. On the completion of this video lecture, student will also understand the concept of electric flux density and the Gauss law and the application of the electrostatics in the several areas where we applied the electrostatic field theory in the daily lives. Now we have come to the introduction about the electric flux density. What is the electric flux density? The field intensity or simply electric field gives the strength of field at a particular point. The electric field depends on the material media because which is based or relative to epsilon naught, and epsilon naught and epsilon r, that is relative permittivity of the medium. So electric field is the based on the material media in which the field is being considered. So electric field is a quantity which gives the field strength at a particular medium or particular point in a medium. The flux density vector is defined to be independent of the material medium. So flux density is not depend on the medium. It is the independent of medium. For a linear isotropic medium under the consideration, the flux density vector is defined as B equal to epsilon naught E. E is the flux density vector, and E is the electric field intensity. Epsilon naught is the relative, it is the permittivity of material. The electric flux phi as phi equal to the surface integral of T dot ds in the form of integral form. So psi is the electric flux, and D is the electric flux density vector. Consider a set of the concentric metallic spheres, the outer one consisting of two hemispheres, which could be firmly claimed together. First, with the equipment dismantled, the inner sphere was given a non-positive charge. Second, the hemispheres were claimed together around the charge sphere with about 2 centimeters of the dielectric material between them. The outer sphere was discharged, connecting it momentarily to the ground. The outer sphere was separated carefully using tools made up of insulating material in order not to disturb the induced charge on each hemisphere and negative induced charge on each hemisphere was measured. This is the Faraday's experiment. In the Faraday experiment, we have charged sphere, that is the positive charge, and metal and insulator. So metal is providing the field, or it is grounding, because charge is on the sphere produce the electromagnetic fields. It can be found that the total charge on the outer charge was equal in the magnitude to the original charge placed on inner sphere, and this was true regardless of the dielectric material separating the two spheres. There was some sort of a displacement from the inner sphere to the outer sphere, which was independent of the medium. This as the displacement flux density and electrical flux is represented by psi. So psi equal to the charge, that is the Q. The electrical flux is measured in the coulombs. The unit of the electrical flux is the same as coulomb, the unit of the charge. The electric flux density is represented by the letter T because of the nature that was given initially, displacement flux density. Displacement flux density. Because charge is displaced in the sphere. So the flux density is represented by the charge Q, that is the flux, electric flux density is represented by the D, and electric flux is represented by the Q, and it is equal to the psi and in the coulombs. The electrical flux density T is a vector. It is a vector quantity and is a member of the flux density class of vector fields. The direction of the D at a point is the direction of the flux lines at that point. And the magnitude is given by the number of the flux lines crossing a surface normal to the lines divided the surface area. The magnitude is given by the number of the flux lines crossing a surface normal to the lines divided the surface area. This is the electric flux in the region between a pair of the charge concentric spheres. In this figure, we understand that the R is equal to the A, radius for inner sphere, and R equal to the B is the outer spheres. So charge is moving from plus to minus, means inner to outer, and the metallic conducting spheres has the outer body is the metallic, and in between of the two spheres we have a dielectric or insulating materials. So this is the phenomena to develop the electric flux in the region between a pair of charge concentric spheres. So this sphere is concentrated with the charge. The electric flux density is the radial direction, in the radial direction, and has a value of E, where R is the radial distance is the A, is equal to Q upon 4 pi A square in the direction of AR, because B is the vector quantity. B R equal to the B equal to the Q upon 4 pi B square in the direction of the AR, and at a radial distance of the R, that is R is less than to the B or equal to the B, and it is greater than to the A or equal to the B. So now we have calculated the flux density, electrical flux density at the distance R. The D is equal to the Q upon 4 pi R square in the direction of AR, vector, unit vector AR. If compare this result with the equation for electric field intensity of a point charge in the free space, that is electric field intensity is equal to the q upon 4 pi epsilon naught r square in the direction of kr. It is also a vector quantity which we have already studied in the previous lectures. So the electric field intensity we depend on the medium, but electric flux density is not depend on medium. So in the free space, on the comparison of the two equations, that is the electric flux density as well as electric field intensity, we get the relationship of charge density, electric flux density is equal to the D equal to epsilon naught E. The figure below shows that clearly what is the flux passing through an open surface. The figure third shows that the electric flux through an open surface. So through which we are able to understand that the how much of the flux is passing through a open window or open surface. Figure E shows that the air flows. Figure B shows the flux, and figure C shows the electric flux, and figure D shows the complete electric flux from a window or a surface, open surface. So this figure shows that the electric flux through an open surface, passing through an open surface, and we are able to understand that how the electric flux density is related with the electric field intensity. In the next section, we have the Gauss law. The Gauss law is defined as the Gauss law is the one of the fundamental law of electromagnetism, and it states that a total electric flux through a closed surface is equal to the total charge enclosed by the surface. Yes, it states that the total electric flux through a closed surface is equal to the total charge enclosed by surface. Total charge enclosed by surface. So here we have the figure shows that V is the density and theta is the angle, and we have a cone in the closed surface, and ds is the surface area in the and theta and an is the normal vector. Gauss law constitutes one of the fundamental law of electromagnetism. It also developed the Maxwell equations. All the Maxwell equations is based on the Gauss law. Gauss law is the particularly useful in the in computing or where the charge distribution has some symmetry. Now we have the application area of electrostatics theory or electric field intensity. In the previous lectures, we have already discussed some important name of the uh, application. That is the electric force in the biology and Xerox copy and printers, scanners. These are the daily life application of our electrostatic field. So we are going to discuss more in the more detail and insight of the application or area of electrostatics. or electric field intensity. So the first application of this is the electric forces in the biology. Classical electrostatics has an important role to play in modern molecular biology. Large molecules such as the proteins, nucleic acids, and so on. So important to light signal and FM modulated signal. These are the combined and transmitted by the transmission section of the antenna. Crystal oscillator generates the allotted picture carrier frequency. Hence, our crystal oscillator it, generate a signal for the picture signal as a picture carrier frequency. RF amplifier, the RF amplifier amplifies the picture carrier frequency generated by the crystal oscillators to required level. So RF amplifier is amplify the crystal oscillator signal to the certain level to meet the as per the requirement of picture AM modulated picture signal at a particular level. Power amplifiers amplify the varies according to the modulating signal from the AM modulating amplifier. Scanning and the synchronizing circuits. The scanning is a process where picture elements are converted into the corresponding varying electrical signals. So scanning is a process through which the picture elements are or scene is developed and converted into the electrical signal, into the corresponding varying electrical signals. So this electrical signal is vary according to the picture or the scene elements. Combining network is used to isolate the AM picture and FM sound signal during the transmission. Transmitting antenna. The transmitting antenna receives the amplitude modulated picture signal and FM sound signal from the combining network for the radiation as a electromagnetic waves. So this is the basic fundamental of the transmitting antenna. So it combines the two signals and by combining network and it radiates in the waves as a electromagnetic waves or in the air, atmospheric airs. Microphones. Microphones is to convert the sound associated with the being picture televised into the proportionate electrical signal. So in the next section, we have simple block diagram of TV receiver. Reception basic monochrome TV. So in the block diagram of TV transmitter, we have a monochrome type of receiver with associated with the monochrome type of the transmitter. So this is the basic fundamental receiver diagram through which we receive the electromagnetic waves or TV signal in the form of radio waves or electromagnetic waves. This signal is received by receiver antenna. So receiver antenna receives the signal and it feeds this signal into the RF tuner. RF tuner is a device which tunes the signal to the particular frequency band. Then we have the common IF amplifier, then video detector, and video amplifier. Here again at the picture tube and video detector, in between of that we have a scanning and synchronizing circuit. Picture tube is a device which converts the electrical signal into the scene. It develops a scene at the phosphorus screen. Video detector is restrict or divide the signal into the audio signal and video signal. So audio signal is given to the sound intermediate frequency amplifiers, and then we have the FM sound demodulator, which demodulate the signal, sound signal from the electrical sound signal. So this demodulation is the process performed by the FM demodulator. Here we will use the different type of the FM demodulator, which was studied in previous semesters. In the next section, we have audio amplifiers. This amplifier is used to amplify the audio signal to the certain level. Then we have at the end loudspeaker to produce the sound from the signal. So picture tube and loudspeaker is a device which performed the scene or picture corresponding to the sound. So this is the complete block diagram of our TV receiver system. The block diagram of a monochrome TV receiver shown in the figure, it consists the RF tuners, receiver antenna, common IF amplifier, video detector, video amplifier, scanning and synchronizing circuits, sound IF amplifier, FM sound demodulator, audio amplifier, loudspeaker, and the picture tube. So this is the complete blocks or complete detail of TV receiver. Now we will discuss the function of the each block one by one. So RF tuner in the receiver system, that is the RF tuner selects the desired channel frequency band from the receiving antenna. It selects on a particular frequency to receive the signal. After getting the tuning or tuned to the particular signal band, then signal is able to receive by the receiver. And our frequency is matched with the transmission as well as the receiver. Receiver antenna intercepts the radiated RF signal by transmitter and send it to the RF tuner. Here we generally use the VHF or UHF type of antenna. In earlier days in the monochrome television, we generally use Yagi-Uda antenna, and nowadays in the color television system or modern television systems or dish TV system, we are generally using our dish type of antenna. It's work on the ultra high frequency, that is the microwave frequencies. So the gain of the system is increased. So the gross image of the picture is reduced. Next, we have a common IF amplifier. There are the 2 or the 3 stages of the IF amplifier as per the requirement of system. How much you want to amplify the signal is depend on the IF amplifiers. That's why we are using here 2 or 3 stages of IF amplifiers. Now we have video detector used to detect the video signals coming from the last stage of the IF amplifiers. Video detector is the device to detect the video signal coming from last stage of the IF amplifier. In the next section, we have the video amplifiers. It amplifies the detected video signal to the level required. Scanning and synchronizing circuits. Scanning is the process where the picture elements uh, are converted into the corresponding varying electrical signal. The scanning and synchronizing is the same as at the transmitter. We have already discussed in the detail. In the next section, we will going to discuss more detail. The sound IF amplifier detected the audio signal is separated and selected for its range and amplified. Sound IF amplifier detect the audio signal is separated and selected for its intermediate frequency range and amplified. The FM sound demodulator, it is a device to demodulate the FM signal in the stage. In the next audio amplifiers, the frequency modulated demodulated audio signal is amplified to the required level to feed into the loudspeaker. Loudspeaker converts the FM demodulated amplifier signal associated with the picture being televised in proportionate sound signal. Picture tube. In the picture tube, the amplified video signal is converted back into the picture element. Next is the scanning process. Scanning is the process used to convert the optical into electrical signal. Fastest movement of electron on the image is called scanning. Means the movement of the electron beam on the image is called the scanning. So through this we are able to scan the image. Scanning process is a technique similar to the reading of written information on a page, starting at the top left and processing line by line downwards to the end at the bottom right. Scanning is a process as a reading of written information on the page, starting from the top left and processing line by line downwards to the end at the bottom right. So this is the just like a reading of a page. Scanning is done frame by frame. Each frame consists of 625 horizontal lines. Each frame is the scanned at a rate of 25 frames per second. Means in the scanning is done as a frame by frame, and each frame consisting of 625 horizontal lines. This is the system or all system which is adopted by the Asian countries or India. Each frame is scanned at the 25 frames per second. This is the scanning rate of a frame. Now we have the four type of the scanning. One is the horizontal scanning. Second one is the vertical scanning. Third, sequential or progressive scanning. And fourth is the interlaced scanning. So in the first type of the scanning, that is the horizontal scanning, is also known as edge scanning. The movement of electron beam from the left to the right on the screen is known as trace period. When the beam returns quickly from right to the left is called retrace or flyback. It is the retrace or flyback period. So in the horizontal scanning, the movement from right to left is known as the trace period, and again return back from left to right or flyback is called retrace period. So there is the trace and retrace, two types of the periods. Trace and retrace period together in horizontal directions is known as horizontal scaling, because this moves from right to left and left to right from a page, from top to bottom. So horizontal frequency is the number of the lines in a frame into number of the frames per second. We already discussed that the number of the lines in the PAL system is 625 and number of the frames per second is the 25 frames per second. So total horizontal scanning is the 15,625 hertz. Here in the figure, the waveform of the horizontal deflection coils is given here, that the first line is shown as a trace period as well as retrace period. Second line, trace and retrace. Third line, trace and retrace period. So it is the curve between the current versus time. Maximum horizontal current and time. Now we have a vertical scanning, the movement of the electron beams in the vertical direction. Movement of electron beam from top to the bottom is called trace or V scanning. Movement of the beam from bottom to the top of frame is called retrace period in the V scanning. The vertical frequency equal to the number of the frames per second, that is 25 hertz. In the edge scanning, 15,625 is the horizontal frequency and vertical frequency is 25 hertz. The scanning process in the vertical deflection waveform or vertical scanning process is shown in the figure A, that is the linear vertical trace top to bottom is shown. Dotted line is shown retrace period and dark line is shown as a trace period. In the B section, B figure number B, we have a retrace period, which is shown as a dotted line from bottom to the top. And current waveform for vertical scanning with time is shown in the figure C, that is the top to the bottom and bottom to the top. Bottom to top is known as retrace period, top to bottom is known as a vertical trace period. In the next, we have a progressive scanning or sequential scanning. This is the third number of scanning process or third type of scanning. In previous, we have already discussed the edge scanning and V scanning. Sequential or progressive scanning is the process in which both horizontal and vertical directions are scanned simultaneously to provide the complete picture. Progressive scanning is a process in which horizontal as well as vertical scanning is progressed simultaneously to provide the complete pictures. Horizontal lines are scanned one by one, and so complete picture will scan through this type. Flicker. The sensation of produced by incident light on nerves of the eye's retina does not cease immediately. It persists for about 1/25th of second, that is 0.062 second. This storage characteristics called as persistence of vision of eye. Flicker means if the scanning rate of the picture is low, then time taken to move one frame to the another frame will be high. This result in alternate bright and dark picture in the scene. This is called flicker because of the movement of the frame from one frame to another frame. Time period is high, so there is the alternate bright and dark picture in the scene, and this is known as flicker. To avoid the flicker, the scanning rate of the picture should be increased, that is the 50 frames per second. So this problem is reduced by increasing the scanning of frames per second. Interlast scanning, it is the fourth type of the scanning in TV systems. To reduce the flicker, the vertical scanning is done 50 times per second in the TV system. However, only 25 frames per second are scanned. So to reduce the flicker, we need to increase this time period to the 50 frames per second. This is done by interlast scanning. In the interlast scanning, the 625 lines are grouped into the two fields. They are called as a even field and odd field. Each field consisting 312.5 lines. Even field contains even number lines. Odd field contains odd number of the lines. So total 625 line system is divided into the two fields, even and odd fields. Each field consists of 312.5 lines. During the first scanning lines, number 1, 3, 5 are scanned. During the next scan line, number 2, 4, 6 are scanned. That is, the alternate lines are scanned every time. So to cover the each frame, scanning is done 2 times. Here the vertical rate of scanning is increased twice. So it will comes on 50 frames per second. So the problem related to the flicker is reduced. So it will reduce the flicker. Interlast scanning is shown. Now the vertical frequency is the 50 Hz, but there is no change in the horizontal frequency. Horizontal frequency is equal to the number of the lines, that is 312.5, and number of the frames per second scanning rate, that is the 312.5 into 50 equal to the 15,625 Hz. So the H scanning lines is the same, or frequency is the same. Now we have a scanning periods. Useful video signals are obtained during the trace period only. So the trace time is larger than the retrace time. Well, our information is carried in the trace period. So its time is big or large as compared to retrace time. Horizontal scanning has in a tracing period is 52 microseconds and retracing period is 12 microseconds. So total time period for scanning one line is 64 microseconds. Vertical scanning period, that is the tracing time is 18.722 milliseconds. Retracing time is 1.27 milliseconds. Total time period is 20 milliseconds. Horizontal frequency is 15,625 Hertz. Horizontal time is 1 upon t equal to the 64 seconds. Scanning periods, horizontal time is equal to the 1 upon t, that is the 64 seconds. Vertical frequency is the 50 Hertz. Vertical time period is the 20 milliseconds. Number of the horizontal line lost during the retrace, that is the vertical retrace time upon one horizontal time, that is 20 lines is lost during the vertical retrace of a frame. So 20 lines are lost per field, and in total 40 lines are horizontal lines are lost during the scanning of each frame. Active number of the lines is equal to the 625 minus 40, that is the 585. So this is the odd lines and the inactive lines, even lines and inactive lines. In the case of the odd field and even field, both active and inactive lines are shown, and each field has total 20 inactive lines, that is retrace period. So total frame consisting 40 retrace line or 40 lines, that is inactive lines. So this is the complete process of the scanning process of electron beam or scene or picture in the television transmission and reception system. So next we have a multiple choice questions. First, that is the modulation is done in A, receiver, B, transducer, C, between transmitter and radio receiver, D, transmitter. In the TV transmission, picture signal is modulated by DSB SC, double sideband suppressed carrier. B is the VSB, vestigial sideband. C is SSB, single sideband suppressed carrier. D is pulse. All modulating television system are use vestigial sideband. Question number third, in the TV transmission, sound signal is modulated. A, phase. B, pulse. C, frequency. D, amplitude. Square law modulators are A, used for frequency modulation. B, used for pulse width modulation, C, used for amplitude modulation, D, used for phase modulation. Question number 5, what is the role of transmitter in the communication system? A, to decode a signal to be transmitted. B, to convert one form of energy into the other. C, to detect and amplify the information signal from the carrier. D, to produce the radio waves to transmit data. Question number 6, what is the maximum transmission efficiency? 67.88%, B 33.33%, C 73%, D 54.03. Why a helical antenna is used for satellite tracking? A, because of its circular polarization. B, because of its broad bandwidth. C, because of its low bandwidth. D, because of rectangular polarization. Which one of the following noise becomes of great importance at high frequency? A, flicker noise. B, short noise. C, impulse noise. And D is transmit time noise. Question number 9, which of the broad classification of the noise are the most difficult to treat? A, noise generated in the receiver. B, noise generated in transmitter. C, external noise. D, internal noise. Which of the steps is not included in the process of reception? A, encoding. B, decoding. C, demodulating. And D is filtering. So today we have discussed about the fundamentals of television system. In this, we have discussed about TV transmitter section as well as TV receiver system. In the next section, we have discussed one by one of block diagram component of TV transmitter and TV receiver. And we have also discussed the scanning process in TV transmitter and receiver system, how the electron beam is converted into the electrical voltage signal by tracing and retracing process. In this section, we have also discussed about the types of the scanning and their benefits and drawbacks. After that, we have discussed the scanning period and retrace period, time, frequency, etc. And in the last, we have also discussed about flickers. So today's lecture is based on the TV fundamentals or TV transmitter and receiver, monochrome type of TV transmitter and receiver section. Thank you.